and he's going to deliver with us TrinaSolar Vertex series. Before he kick off his presentation, I would like to give you a brief intro about Lin. Lin is handling product and marketing epic at TrinaSolar. He's joined Trina in November 2011 and has been responsible for product management, training, and the promotion of new products to APAC customers. He has over 9 years of PV industry experience and is supporting a broad base of customers in different segments, product and technical team. Hi, Lin. I leave my floor to you.
Yeah, hi, Jessica. Thank you. So let me share my screen.
Okay.
Yeah. Okay. Thank you again, Jessica, and to all the participants. Thank you for your time today.
Can you make it full screen? Maybe. Yeah. Yeah. Perfect. Perfect.
Okay.
Thank you so much.
Thank you. Yeah. Thanks. So once again, thank you everyone for the time today. I'm Lin from TrinaSolar. So I would like to give a brief introduction about TrinaSolar and also our latest product. So this is a brief background of TrinaSolar. We are founded in 1997. We have more than 20 years of experience in the solar industry. And these are the few key milestones in the growth of TrinaSolar. So of course, last year was a major milestone where we relisted onto the Shanghai Star Market. And we also launched our 210 mm modules together with the high power bins into the setting the benchmark for the new PV era. So in terms of globalization, we have offices all over the world. So myself, I'm based in Singapore. So from Singapore, we are supporting the namely the ASEAN region and also Australia and also to India and towards the Middle East. So cumulatively, we have shipped more than 70 gigawatt worldwide. And we have over 15,000 employees located all over the world. So from the latest Bloomberg New Energy Finance report, I'm happy to say that Trina has achieved once again the top most bankable module supplier. So this is the 6th time in a row ranked by Bloomberg New Energy Finance. And we have been expanding rapidly in the Asia Pacific region. So over the last 3 years, we have shipped almost 9 gigawatt of modules, and this put us firmly in one of the top 3 module suppliers in the region. So in terms of leading technology-wise, I think since last year, we have launched our 210 mm modules. And then with that, we are also looking to launch our N-type Interconnection modules very, very soon. And we are also actively researching on the advanced HJT technology, which might be coming sometime like next year or so. So this is just a brief background of how module power has transformed over the last 10 years. So you see in 2009, we only have 290 watt, but over the last 2 years, we see the rapid increase in the power bin that we can get from the solar module. So namely from 2020, first half, we have 500 watt, and then from then on, it was like a 50 to 100 watt increase every 6 months. So now we are looking at almost 670 to 700 watt, which will be coming very soon, probably next year. So of course, in one of the major exhibitions in China in June this year, SNEC, we see that more and more module suppliers have adopted the 210 mm module size, and these are offering power bin in a 600 watt to 700 watt range. So from Trina ourselves here, we have already started supplying, and this is just a glimpse of what we have supplied before, and also we have a healthy pipeline that is requiring all these high power modules. So even in our region itself, we have supplied for Singapore floating projects and a couple of other big projects in Vietnam also. So this is our comprehensive Vertex family. So you can see here our product range, namely there are 5 series. So it covers from the residential to the commercial and industrial rooftops, and of course to large-scale utility projects. So the power bin range from about 400 watt all the way up to 670 watt. So these are the 4 key technologies that we are using in Trina Vertex module. So starting from the top left corner, that will be the largest wafer size available, which is 210 mm. And then with that, we are also using the multi-bus bar technology. And with the larger wafer size, we have changed from the conventional cutting method to a non-destructive cutting. So this enables us to get a similar mechanical loading for our solar cell despite being larger in size. The last one on the bottom right is our high density interconnection technology. So essentially, this is to reduce the gap size between the cells so that we can optimize the dimension of the module and help to improve the efficiency. So just to dive a little deeper into our 210 mm Vertex module. So these are available in 550, 600, and 670 watt, both in monofacial and also bifacial. One of our key design advantage of the Trina modules is that this is based on a low voltage, high current design. So you can see here the voltage is only about 38.1 volt as compared to the others, which will be in the range of about 47 to 49 volts. So when we put this into system level, how does it help us? So basically, we are able to increase the power pushing by connecting all modules into one string. So using this example, you will see that for this particular site, conditions of -10 degrees, 1500 volt system, Trina 210 mm can connect up to 36 pieces module per string, as compared to the 182, which can only connect about 27 pieces. So there's about 35% more power per string as compared to 182. So this is a critical factor that will help us save on our balance of systems costs. So this is an interesting table, which we have mapped out how the string power has evolved over the last 10 years. So you can see previously we can only connect about 10 pieces of module per string. Until now, we are able to get almost like 35, 36, depending on the actual site conditions. So with the increase in modules per string, this actually helps to drive down the BOS costs. So next generation, probably, if we can see the 2000 volt system coming up, then of course we can connect even more modules per string, which will help to further drive down the cost. So using an example here, we also make a case study for a rooftop project. So this is based on a 1 megawatt rooftop where we compared the 210 versus the 182. So we can see here the key savings are coming from the less DC cable use, and then there's less mismatch losses as compared to two strings, and also lower failure risk as compared to two strings when the rooftop has shading and complex design. So this is a typical array. Usually we break up the whole system into multiple arrays. So this is an equipment build comparison. So from here you can see that we are getting savings from the connectors and also from the cables. So this is just a bit more details when we put it into the graph perspective. So basically the string numbers reduce, the module numbers are also reduced because of a slightly higher power bin, and overall cable lengths are definitely reduced. So from this case study analysis, we can see that basically we can save up to about 0.0064 per watt as compared to the 182. So just a bit more details on our ultra high power 670 watt module. So as mentioned, this is based on a 132 cells layout. Size about 2.3 by 1.3, and we are offering it in both the monofacial and bifacial variant. Similarly, it's also based on a low voltage, high current design concept. So in terms of reliability, we have done a lot of work and testing to ensure that this ultra high power large footprint modules have the same mechanical performance as compared to the conventional module. So we are able to achieve the standard requirement, 5,400 Pascal front and 2,400 Pascal back. So this is achieved mainly from the optimal design of our frame. So we have done some changes on the frame thickness enhancement, the frame chamber, and some of the cross pin and connector design optimization. So to support this, we have also done 6 tests, including the static mechanical load test and 5 other tests like the non-uniform snow load, extreme low temperature mechanical load, hill dynamic load test, and the wind tunnel test. So this details are available on our website. So if you're interested, do visit our website with the link here. Then you can read more about the different tests we have done to ensure the performance integrity of the Vertex modules. So another thing that we want to highlight here is that because the modules are bigger in size now, so on the left is the conventional packing method where we have the modules are packed horizontal and stacked two on top of each other. Then for these large modules, we are using the vertical placement method. So you can see the modules are actually packed vertically. This is how it will look like inside a 40-foot high cube container. So because of the higher power bin, even though we have less number of pellets per container, we can actually still pack more power per container as compared to the others. So just a few weeks back, we have released another study that we have a partnership together with Fraunhofer, where we compared between different module size or a different cell size that was put into the module. So there's M6, M10, and G12. So G12 is our Trina Vertex ultra high power, the 670 watt. So we have done it comparison on 2 different locations in Europe. So Germany is fixed, and in Spain is a one-row tracker. So the conclusions are quite similar. So by using an ultra high power module, we are definitely able to get the best LCOE at both locations as compared to the other modules. So because of our module is low voltage, high current, so we need to be compatible with the top major inverter suppliers. So for central inverter, there's no major issue. Then for string inverter wise, we have already worked with the major inverter suppliers. So most of them has a compatible model that is already available or coming very soon, next 1 to 2 quarters. So similarly for large scale projects, we have also worked with the major tracker suppliers. So their design is already compatible with Trina large high power modules. So lastly, these are just some of the case studies that we have done before, how we can deploy these modules onto the rooftop itself. And just some examples that we have installed by our clients in the Asia Pacific region. Okay, so with that, I've come to the end of our presentation. Thank you very much, everyone, for the time today.
Thank you, Lin. Thank you for your presentation. Thank you. Dear our audience, if you are interested in Trina, please contact me.